In this video, we will discuss elements, symbols, isotopes, and relative atomic mass. Let's recap the makeup of an atom. An atom is made up of a central nucleus, which contains protons and neutrons. Orbiting the nucleus are electrons. These are the basic particles that make up an atom's structure. To define which element the atom is, we need to look at the number of protons. Let's look at the lightest element, hydrogen. Hydrogen has one proton in its nucleus and one electron in orbit. The next smallest element is helium, which has two protons and two neutrons in its nucleus and two electrons in orbit. If we had an atom with 3 protons, then it cannot be helium. The protons are unique to each element. We would need to look at the periodic table to find an element that has 3 protons within it, which on the periodic table would be lithium. To recap, we can define an element as a substance made up of atoms that have the same number of protons in their nucleus, or in other words, an element is a substance made up from only one type of atom. For example, carbon is made entirely from carbon atoms as shown in this image, and lithium is made entirely from lithium atoms as shown here. The periodic table shows all the elements. There are over 100 different elements, and each box is called a nuclear symbol. The number of protons in the nucleus decides what type of atom it is. For example, if we take a look at hydrogen, the lower number on hydrogen is called the atomic number, and it is unique to that element, and it represents the number of protons in the atoms of that element. And any atom with that number of protons within it must be that element. Atoms of the same element have the same number of protons, and therefore have the same atomic number. Let's take another example. Carbon. It has an atomic number of 6. Therefore, the number of protons is 6. Another example is hydrogen, which has an atomic number of 1, and therefore has 1 proton in its nucleus. In summary, all atoms of a specific element, for example carbon, have the same number of protons, and different elements have atoms with different numbers of protons, as we have seen the difference between carbon and hydrogen as examples. Let's talk about symbols. Within the periodic table, atoms of each element can be represented by a 1 or 2 letter symbol. This is an easier way of identifying elements instead of writing the full name. Each symbol starts with a capital letter. Some make logical sense. So C stands for carbon, N stands for nitrogen, and Mg stands for magnesium. Others are more confusing, such as Na stands for sodium, and Fe for iron. Most of the odd symbols are a result of Latin names in the elements. Although this periodic table shown only has the symbols, most periodic tables have both the symbol and the name of the element if you're unsure of what the symbol means. Let's move on to isotopes. Atoms of the same element must have the same number of protons, but they can have different number of neutrons. Isotopes are different forms of the same element, which have the same number of protons but different number of neutrons, or put another way, they have the same atomic number but different mass numbers. Let's take a look at carbon, where carbon has a pair of isotopes. We have the more common carbon-12 and the rarer form of carbon-13. Carbon-12 contains 6 protons, 6 electrons, and 6 neutrons, whereas carbon-13 still contains 6 protons, as it is carbon, 6 electrons, but has 7 neutrons, 1 additional neutron compared to carbon-12. This means it has a mass number of 13 rather than 12. They are both still the same element, but with different mass numbers. The physical properties of isotopes are different. Isotopes can have varying physical properties because mass determines physical properties such as density, boiling, and melting point. Chemical properties of isotopes are pretty similar. Chemical properties are determined by the number of electrons, which is the same in isotopes. Therefore, they have the same chemical properties. Let's discuss relative atomic mass. As we have seen, isotopes have the same number of protons but different numbers of neutrons, giving rise to different masses. As we have different masses, we need to be able to calculate the average mass of all the isotopes that make up that specific element. As many elements can exist as a number of different isotopes, we use a term called relative atomic mass. which is represented by the symbol A subscript R, instead of the mass number when we refer to the element as a whole. In summary, this is an average mass taking into account the different masses and abundances amounts of all the isotopes that make up that element. The relative atomic mass can be written as a formula, which is the relative atomic mass denoted by the symbol A subscript R is equal to the mass number of isotope 1 multiplied by the percent abundance of isotope 1 plus the mass number of isotope 2 multiplied by the percent abundance of isotope 2, and this is divided by the sum of the abundances of all the isotopes, which in most cases is 100. When we mention abundance, we basically mean how common or rare the isotope is. You may be asked in the exam to calculate the relative atomic mass of an element to 1 or 2 decimal places. Let's take the example of copper and work out its relative atomic mass. Here we have two isotopes of copper, copper 63 and copper 65. Copper 63 has an abundance of 69.2% and copper 65 has an abundance of 30.8%. So if you held a handful of copper, 69.2% of that will be copper 63 isotope and 30.8% will be copper 65 isotope. If we take copper 63 to be isotope 1, in the formula we multiply its abundance of 69.2 with its mass number of 63, and then we do the same for copper 65. So we multiply its abundance of 30.8 with its mass number of 65, and then we sum these together. Finally, we divide this by the sum of the abundances of the isotopes, which would be 69.2 plus 30.8. So calculating 69.2 times 63 gives us 4,359.6, and 30.8 times 65 gives 2002. And then we add these to get 6,361.69, and then we divide this by 100, which gives us 63.6169 as our answer. But since the question asks for an answer to 1 decimal place, we get a final answer of 63.6 as a relative atomic mass. So the average mass of copper atom is 63.6. That's all for this video. Hope you found this useful. If you did, please give a like and subscribe, and I will see you in the next video.